So an exoplanet is a planet that orbits a star outside of our own solar system. And most of the exoplanets that have been discovered to date have been discovered through indirect techniques, where we see the effect of the planet on the star it's orbiting and then infer the planet is even there or something about the planet. But now we have this new technique called direct imaging, where we can take an actual direct picture of the light coming from the planet itself. And so this really has opened up a whole new era of exoplanet discovery, where we can learn a lot more about the planets themselves, and in turn we can maybe learn something about our own solar system. So measuring the light coming from these planets is extremely difficult, because it's kind of like trying to look at a firefly right next to a spotlight. The planets are just so much fainter than the star. But we can use special techniques and cameras to try to really get a good picture of the planets next to the host star. And so this is what we did for a planetary system called HR 8799. And this planetary system has 4 gas giant planets, all about 5 to 7 times the size of Jupiter. And they orbit more distant than the gas giant planets in our solar system for the most part. So the closest one orbits at a distance about the same distance as Uranus from the star, and the furthest one orbits at a distance beyond that of Pluto. So because we can see the light directly coming from these stars, we can actually do something really exciting, which is figure out what they're made of. And so we do this with a technique called spectroscopy. And this is where we break the light down into its constituent parts as it comes from the planet. And then we look for the fingerprints or signatures of different atoms and molecules that are living in its atmosphere. And so this is just what we've done for one of the planets in the system, which is called HR 8799c. And so for this Jupiter-like planet, we've determined that there's a lot of water vapor and carbon monoxide in its atmosphere. And so it also has a lot of different interesting properties, like it has clouds of dust in its atmosphere. So even though we did find water vapor in this planet, we know that it's extremely hostile to life as we know it, because there is no solid surface on this planet, and it's also about 1,000 degrees. So it's really hot and has no surface. So there's probably no life. But we can use these molecules to actually tell us something about how this planetary system may have formed. So what we've done is we looked very precisely at the amount of water vapor compared to the amount of carbon monoxide, and we think that what this tells us is that there was slightly less water vapor in the disk that formed this system at the location of this planet. And so there's a model that we know called the core accretion scenario that predicts that the water vapor in this disk of material that surrounded the star when it was young would condense and form ice particles. And then these particles would all stick together and grow and eventually form what's called a planetary core, and acquire about 10 times the mass of the Earth in material, and then start finally being able to suck up gas around it and accrete a bunch of gas to make an atmosphere. And so this atmosphere would then be depleted of the water that was in the ice form. So this is called, again, the core accretion scenario of formation. And so the fact that we think this planetary system formed this way is really interesting, because this is also how we think the solar system may have formed. And so in many ways, the HR 8799 system does look like a scaled up version of our own solar system, because it has these 4 large gas giant planets at large distances, and then interior to the closest planet, there's a belt of material kind of like our own asteroid belt. And then exterior to the furthest planet, there's another belt of material kind of like the Kuiper belt or the Oort cloud. So because we think maybe it did form like the solar system, it wouldn't come as a surprise to find that there are rocky or terrestrial planets closer to the star that we can't see. We don't really have the technology at this point to be able to see these kinds of small planets really close to the star, but maybe in the future, as new telescopes and new cameras come online, we will have the technology to see them. So what's really exciting is there's an international team of astronomers, including people at the Dunlap Institute, that are working on a new system called the Gemini Planet Imager. And this system is going to really revolutionize directly imaging exoplanets. It's going to go on the Gemini telescope in Chile at the end of 2013, and it's supposed to discover up to maybe 100 new exoplanets through direct imaging. And so once it discovers these new planets, it can look up their chemical makeup, just as we've done here, and maybe learn a lot more about planet formation in general. So by studying these directly imaged exoplanets, we learn a lot more about our own solar system and our own planet, and possibly our own place in the universe.